All right, let's get started. So, sorry about that delay. I was just answering some of your perusal comments and thought I could get more done than I ended up being able to. So we stopped last time while I was doing a Vensim demo, and I just want to finish the Vensim demo and give you a quick intro to Insight Maker as well, and then we'll flip to the normal content after that. So I'm now sharing the screen on the local computer here. So when I start up Vensim, it should look, I think, like the new sketch. So this will give it a little bit of a diversity in this example, but it looks like this one's actually configured to be old sketch. So that's fine. If I want to switch to new sketch, I guess I can do that. So now I'm in new sketch mode. Oh, sorry, right, okay, sorry, I thought I had this cloned. Let me just switch the display here. Or go back to Zoom. Let's try that again. Oh, right, sorry, that was the issue. Let me flip so that everybody in class gets the same view. Okay, now that I think should be working. And just anticipating what I'm gonna do next, let me change the share a little bit. Okay, so everybody online should see my Vensim, everybody in class should see my Vensim. So I'm gonna go ahead and change the font a little bit here, just for those in class, so that it's a little bit bigger. It's probably bigger than I need. So I did this bacterial growth example before. I'm gonna do the same sort of thing, but I might skip a few steps or make it a little bit of a simpler model just for time. But the basic idea here is I can go up to the stock tool up here. So before we were only using the variable tool, which is that little A box, but the stock tool up here, it's got that little S around it. That's how I develop these stocks or these asset stocks that you read about in the chapter. So I can call this bacteria, draw something like that. Then because it's a stock, I can do these things out of order. So I can say well, I'm not going to do that. So a stock is going to need flows in order for it to change, or rates. And so up in Vensim, there's this tool, this thing up here, the flow tool, or in the old sketch, it's called rate. And you can click on that rate or flow. Then you can click outside of the bacteria and then let go. And then go and click on bacteria, and it will draw a flow showing that it isn't pulling from anything. So as there's flow into the bacteria, it doesn't cause outflow from anything else. And I can call that like population birth rate, for example. Then I can also click on the bacteria, go out, click anywhere else, and I can call that population death rate. So those are my two flows. In order for me to write the formulas for those flows, I have to think about what information I need from, I need to go to my microbial friends and say, how do I model the population birth rate? And then they might tell me that every bacterial has a certain average time between reproduction and has a certain average lifetime. So I know that I can get those from my bacterial friends. And so I go in my variable tool and I say average time to reproduction is in there. That's something that's measurable. And then I can create average lifetime, and that's measurable. And I can either connect those directly to my rates, or I can create additional converters. Like I could create an individual birth rate and an individual death rate. Or like I say, I can go directly to the population birth rate. So just to show some diversity from last time, I'll go and I'll click the arrow tool, this link tool up here. It's a little blue arrow in new sketch. It's a similar diagram in old sketch. And if I click on average time to reproduction, I can connect it directly to this rate, grab the little handle, I can see it's connected to the rate. So I can decide how I like that. Want to draw that. And then I can do the same thing for average lifetime. So this is a deviation from what I did last time, because I'm skipping those intermediate converters. I'm just going to bring them directly into the formula. So then now I've got my basic diagram drawn. So I can go and I can click on this little f of x equation tool over here, and I can then click on that, and it will highlight everything that needs its equation to be filled in. So I can go and start clicking on them, average time to reproduction. And I know that my microbial friends told me this was 0.75, matching what we did earlier. So I'm going to fill in 0.75. I know they told me my average lifetime was 3. So I'm going to fill in a 3 there. And then down here under population birth rate, I know that is going to, so that reminds me of a link that I forgot to draw. In order for me to get the population birth rate, I know that I'm going to need to do, like we said last time, bacteria divided by average time of reproduction. In order for me to put bacteria in here, I need to draw a link. Otherwise, if I click on this population birth rate, it shows me everything I'm allowed to use in the formula down here. And this average time to reproduction is the only thing I'm allowed to use. I'm not allowed to use bacteria. So I'm going to go and hit cancel here, go up to the link tool, draw from bacteria to population birth rate, and then also draw from bacteria to population death rate, because I know I'll need those there. Now, if I go to the equation tool, both of those are available down here in this box. Both are available for me to use in my formula. So I can write any formula of these two variables, but I know that for this type of flow, the inflow is typically going to be the number currently in the population divided by the average time until reproduction events. So that's what I'm going to do here. It's bacteria divided by average time to reproduction. All right, so before I go far, are there any questions on that? Everyone feel pretty good about that?
The only thing I missed out was how you got to highlight everything that needed the equation, but what that tool looks like.
That it's tiny up here, but it says this little FX up here, okay. Equation tool. If you click that, everything that needs an equation will turn black.
Fantastic, thank you.
Any other questions, online questions? Good, all right. Yeah, I'm sorry.
So are we gonna like later on be able to just add a number somewhere and it like pops out the like solution because it has already formulas in it? Like we already entered like number.
Well, so we did enter a number. We entered the 0.75 there. And we entered the 3 there. The solution will be the behavior over time, which will be that graph.
Oh, right.
Okay.
It won't show like any numbers, it's like the graph.
Well, so we'll actually, and I'll show you here at the end of this, I'll show to generate a table identical to the table you generated in Excel as well. Okay, any other questions? Right, this is exactly like what you're going to do with the toilet model, but instead of drawing the bacterial system, you'll draw that even simpler toilet model system. Okay, so now I need to go to population death rate, and I see that I have 2 variables available to me, bacteria and average lifetime. And I know for this type of flow, I divide the number of individuals by the average time between events, in this case, deaths. So I'm going to do the number of bacteria divided by the average time between deaths, which is the average lifetime. And I didn't spell average right, but that's okay. It's easy on me. So that's average and alternate spelling of average there, but hopefully yours is got the E, or the A and the R in the correct position. And then I click OK there. The last thing I need to do is click on the stocks. Now, when you click on the stocks, there's a temptation to try to edit this box in the top here where it says integ next to it. Don't ever touch that box. That box is automatically updated whenever you connect a flow to the stock. So if you connect an inflow, it'll add the inflow on the left-hand side. If you connect an outflow, it'll put the outflow on the right-hand side. So that integ means integral. So it's creating this little integral thing there for you. So you don't ever have to adjust the formula there. You do have to put in an initial condition. So for our initial number of bacteria, I want to put in a 1. For the initial water level in the toilet, I might want to put a 0. So I adjust my initial conditions based on the system. So this has 1 bacteria starting in the system. So then I click OK. So all my formulas are there. What's the one thing that I still have to set up? So I've set up all of the formulas. I've set up the initial conditions, the converters. what's the one thing that's really important when you do these numerical simulations of systems? It's like the top thing in your spreadsheet. Well, in your spreadsheet, so it's like A1. Yeah, DT, that's what I was looking for. Is that what you were going for too? Yes, great. DT is what I'm looking for. DT is not anywhere in here. DT is hidden from us off the diagram. And we find it by going into model and then settings. It says, please save the model first. So I'm going to do that. File, save as, and I will just save it somewhere. So I'll see if it'll allow me to save it on the desktop. Okay, I was happy with that. So now if I go to model and then go to settings, it brings up this thing here where now I can select these units basically affect what's going to plot on the graph. So I could choose the units I want, but this is aesthetic at this point. Then I can say my initial time and final time. Well, I want to simulate this for 5 time units, or in this case, 5 seconds is what I'm claiming a time unit is. Time step down here, this thing here, time step, that is the DT. And so that is where we decide we can go in and we can change it. We can leave it at 1, we can change it to 0.01 or whatever. I'm going to set it to 0.01, but but just like in your Excel spreadsheet for assignment D1 or D1, where I had you try different DTs, you frequently want to do pilot studies with Vensim where you try different DTs here until you find the sort of the largest DT that causes your system to settle down, and you don't want to go any smaller than that. If I set this really small, I mean, might even be able to show you here. If I set this to, don't do this, but say I set it to something really small like that, I'll save. If I hit this play button, which generates data, notice that this pops up, which normally you don't see. This is the computer simulating those tiny, tiny, tiny little time steps. And one run of this simulation is taking forever. So this tells me that I've set my DT probably lower than I needed it to be. So that's why we don't just set it to something really, really small. So I'm going to hit cancel there. Say I don't want those results. It tells me problems were encountered, no kidding. So I'm going to go to my settings and I'm going to change this time step to 0.01. Now, when I do that and hit play, it's like nothing happened because it simulated that quickly. So it got to the whole 0 to 5. So now at this point, it didn't show me any results. So if I want to see results, I have to highlight what things I want to plot and then plot them or export them as a table of data. So if I want to plot them, I'm going to go to this move tool up here. I can also do it in the lock tool, and I can highlight the things that I want to plot. So I could plot these 3 variables, population birth rate, bacteria, and death rate, just by highlighting them. Then I can go over and hit over on this left-hand side, there's this little thing that says graph. When I mouse over it, it looks like a little red squiggly line in New Sketch. In Old Sketch, I think it actually says the word graph. And I think in New Sketch, I can actually tell it. So I'm gonna maybe, in New Sketch here, there's actually a way to configure your preferences to put words back on it, which is sometimes helpful. And I'd have to double check where that is. I think it's under options somewhere here. I don't know, I'd have to look offline, but I know that I've toolbars show icon labels. So if I do that, no, it still didn't do it. Well, I'd have to work on that, but I think I can put words back there. But it's the little red squiggly line on the left-hand side here. If I click that, it's going to take all the data that were generated in that run, and it is going to generate a plot for it, just like we would see in Excel. And notice there are 3 lines, and that's because I highlighted 3 things. And it shows me the blue line is bacteria, the red line is population birth rate, the green line is population death rate. And I can see them here, and it happened to be able to plot them all on the same axis because they were close enough. If I don't want to see some of those, I can go and uncheck them. So I don't want to see population birth rate, I don't want to see population death rate, I want to just see bacteria. And I can see, just like in our Excel model, after 5 time units, it hits about whatever that was, like 140 or something like that. So it's exactly the same as what we got in Excel. Now, you can take this and I can say edit, copy, and then I could open up Microsoft Word or something else. So wait for Word to come up, go into a blank document, and then I can go in and paste it. So I can right click somewhere and say paste, And there it is. It's right in the Word document. And it has the legend and everything. That's one way to do it. But I can also export data to Excel. And that way I have more ways to update this to make it kind of a cleaner looking graph. So let's see how to do that. I can go in to this here. And instead of hitting graph, with those three things selected, I can go down to the left-hand side here, and it's got table and table time down. If I click table time down, it generates something that really does look exactly like the spreadsheet. So let me see if I can make this any bigger. I don't think it's gonna, there it goes. So you can see here, I've got population birth rate, population death rate, and bacteria. This is exactly what we generated. If I scroll to the top here, and you can see the time. So you can see every time step is separated by the DT, 0, 0.01, 0.02, exactly like the spreadsheet. This is our stock column, bacteria, exactly like the spreadsheet. This is our inflow column. This is our outflow column. So we've generated all the same data that we would have generated in the spreadsheet. And from here, I can actually say file and then save. And it allows me to save a text file. So I can call this bacteria, and it'll save it as bacteria.txt. And then if I go and I find that bacteria file here, if I were to double click on it, it's going to open it up like this in a text editor, which isn't that useful. But if I instead go to Microsoft Excel, and you can also do something very similar in Google Sheets, and I go into Excel and I say I want to open a file. So open other workbooks. I'll say this PC or browse, select desktop, and I'm going to select text files. It pops up bacteria. And then it's going to say, this thing doesn't look like a normal type of file. It must be something else, like it's not a normal comma separated file. So I know it's space delimited, which means every column has spaces in between it. So what I'm going to do is I'm going to say it's delimited, and I am going to select that it is, oh, it looks like it figured out when I went forward after delimited that it's tab delimited. So you can see it's showing me a preview. It's going to take all of these times, all of these stocks, all these inflows, all these outflows. And then if I hit next here, and it asks me what are the format here, so I can do those sort of, but it finally brings up the exact same thing that I had before, and I can go and play with the charts are in here. So if I were to say, generate a scatter chart, again, it's exactly the same as what we did in Excel, but I didn't have to type in all of those ugly flow update formulas. And now I can go through and I can add axis elements, titles, etc. So that's how, in a nutshell, we can get in Vensim to exactly the same outputs we would have gotten in a spreadsheet. We can generate graphs very quickly inside Vensim, and we can do more sophisticated graphing inside Excel by exporting data from Vensim. So that's how we do it all in Vensim. So are there questions about that? Yeah.
Was that graph or table?
The table down?
And what do you do after that to save that?
Yeah, right. So if you go back, if I go back to Vensim here, inside here, if I say file, save, then it says save as text. And so I can type in a file name and it'll save it as a text file. And that's what I did, is I just saved it as bacteria.txt. And then from there, I have to go into Excel. I can't just double click on it. I have to go into Excel or Google Sheets. And then I have to say, I want to open it. And then I choose to open it. And then Excel will say, this isn't a normal looking spreadsheet. It looks like it might be a delimited text file. So I say it is, it's a delimited text file, it's tab delimited, and then it pulls it all in, and then I just treat it like a normal spreadsheet after that. Yeah.
Oh, this was kind of near the beginning, but how do you load them?
Okay, so if you get a weird error like a run isn't loaded or something like that, that means that you probably haven't hit the play button yet. So if I go back here, you have to make sure that I hit the run a single simulation. That will generate data for the simulation that will then, and then the graph draws from that data. And so we can actually see signs of that, because I bet if I look on my desktop here, I started out with bacteria.mdl, see down here on the desktop, bacteria.mdl, but other junk got loaded up there. And this thing up here where it says current.vdfx, and then, yeah, I think that's that current.vdfx, that's actually where the data was stored when I hit run. So it generates that file. If that file doesn't exist, then whenever you try to graph, it's going to say, you need to load a run. So, so in principle, you can actually run your different types of simulations, like for different birth rates and things like that, and you can save them to different files, and then you can tell it, instead of running, go and load this file that I've already ran before. That's more advanced. So instead, we're just saying, go ahead and hit play, and then it'll generate that. And then when you hit graph, it knows to load the thing it just generated. All right, any other questions about basically getting these simulations running in Vensim? I know it's a new program, but I hope it's pretty clear that this is much easier to get up and running than Excel. And what's really great about it is if you wanted to quickly modify this, if I want to like add predators or whatever, I can just drop those things in, hit run, and I'm done. I don't have to like rethink all the columns I have to add and stuff like that I would do in Excel. And it's nicely graphically portrayed. All right, so that's Vensim. Some people like Vensim and it works great. Some people don't like it, maybe it crashes or whatever. So the one other tool that I want to show you, and that's Insight Maker. So Insight Maker, you don't have to install. You can open up in a web browser, and I can go to insightmaker.com, and you can create a free account if you haven't already. I have, so I'm going to click login. I'm going to put in my email address and I think my password associated with the account. And it's got a bunch of these mostly junk models that I've created while teaching classes like these. And so in Insight Maker, you might have an empty desktop like this or not, but you can hit this create new insight up here. And it gives you a blank canvas, just like well, it gives you this tutorial, which you can follow, and it's great to do. But if you're used to Insight Maker, you can clear that demo model, and then it gives you a blank canvas, just like in Vensim. And then we do a very similar process. So I can go up to add primitive, and I can say add stock. So then I create a stock, and look, it's a box, and it says new stock there, and I'd like to edit that name. So I can double click on it and I can type bacteria, or if I click on it, this thing on the right changes and it's got the name up here, and I can also change it here. So there, bacteria. And if I mouse over this thing, it's got a little equal sign, and that'll be where we'll end up being able to change the initial conditions. So I'll be able to, I can even do that now. I go into here and I can say I want one bacteria initially. So now I want to draw flows. Now this is a little weirder than an Insight Maker. I go up here at flows transition, I click on that, and then instead of clicking on the source of the flow and then drawing it to the sink like what in Vensim, I have to do something a little weird. I click on one of these little arrows in the middle that anchors the flow, and I drag it away, and that creates an outflow. Well, that's the wrong direction. So I then click this little reverse guy up here, and that turns it to an inflow. And then I can name it. Again, maybe just double click on this guy, or if I can't manage to get that to happen, I'll go up to this right here. I can call this pop birth rate, just like before. To do an outflow, I do the same thing. I click on flows transitions, I drag out. This is in the right direction. So I'll click on this guy, and then I'll say this is pop death rate. And then I need to draw my links. Up here, in order to draw links, I switch to link drawing mode, and then it's the same sort of thing, where I would say that I want to take bacteria, and I want to drag it to population death rate. Now you can't really see it very easily, but when I did that, I dragged bacteria to population death rate, it drew a straight link with a little dashed green line that's right over top of this. That's not a very useful visualization. So I'm going to, and this is a trick here. So listen in. This is like a Vensim kind of pro tip, I have to hold down shift. So those online, I'm holding down shift. And then I click somewhere in the middle of this link and then let go of shift. That's critical for this next part. Shift should not be pressed. When I held down shift and clicked on that, it added a handle, just like in Vensim. If I would keep holding down shift and click on that handle, the handle would disappear. So I gotta let go of shift. Then grab that handle and pull it up. Vensim like I got my, my link there. So I'm gonna do the same thing here. I'm in link mode. I drag bacteria to death rate, hold down shift, click in the middle, drag it up without shift being clicked. And then I got my two links there. Yeah.
How do you those arrow again?
There's this little arrow back and forth right there. So if you click on the flow, you can then click the reversal and it should move the head the other way. Okay, now I'm gonna add two variables here, just like before. This variable here, I'll call it the average lifetime, or no, sorry, average time to reproduction. And the other variable, I'll call it average lifetime. And then I will draw my links. I'm in link drawing mode, so I just have to grab this little arrow thing, drag it down to death rate, grab this arrow thing, drag it down to birth rate. I'm okay with straight lines for those, so leave it like that. Looks very similar to Vensim. So now all I have to do is update my formulas. So if I mouse over each one of these, there's that equal sign that I can click on. If I just click on them, there's also this value equation that shows up on the right, and that's an alternative way to get to the equations. So I'm gonna just hit the equals things here just for some diversity. And I know my average time to reproduction is 0.75. My average lifetime is 3. If I go to population birth rate, the equal sign on this flow shows up over here. I click on that, and then it says references. And this is what, these are the things that I'm allowed to access because those links are drawn. And so I'm just gonna do bacteria divided by average time to reproduction. So I click on bacteria divided by average time to reproduction. And then I end up getting those, see those bracketed things, bracket bacteria divided by bracket average time to reproduction. I can do the same thing for the death rate. I go to the population death rate, I hit on the equals here, bacteria divided by average lifetime. And then all that's left is my initial condition, which I already set up in here. Now, one thing I wanna note is that by default, and I don't like this, it says restrict this flow to positive rates. Now, a lot of systems modelers do not like this because this creates a dynamical element that's not reflected in your equation. It's very subtle here. So this is saying that if your flow happened to calculate a negative number, it will automatically just force it to be 0, which sounds convenient, but you might have an error in your flow that you're not gonna catch because of this. And we're gonna see examples of that as we move on after the midterm. So I am going to turn off this restrict this flow to be positive rates. Now the downside of that is when I hit apply, it puts another arrow going backwards that's not filled in. So it looks a little funny. What it's trying to say is the positive direction is the filled in side and the negative direction is the unfilled side. So it doesn't quite look as good, but I like this functionality better. So I'm gonna go and do that to the other one too, where I uncheck that restrict this flow, and then I get these ones. It won't make a difference for this model because these flows are always positive by how they're constructed. But generally, we kind of want to turn off that restriction whenever possible. So now we're almost done. What's the thing that we need to do next? Same as before. In the back, you raised your hand before and I didn't give you the opportunity. Yes, so what's the thing that we're missing out on? Same thing in Vensim. It's the same answer you're gonna give before. What was that? The DT, that's right, that's right. So, so just like in Vensim, DT is hidden. We have to find it elsewhere. Where might we expect it to be? Settings, just like in Vensim. So I hit settings and simulation start, simulation stop, 5. I'll make them seconds. And then simulation time step, just like in Vensim, it defaulted to 1. I'm going to make it 0.01. All right, so now I'm ready to run this thing. So if I click simulate, it actually generates a graph. And I don't know why they do it this way, but it's not actually taking this long to calculate. Just for dramatic effect, it slows the unrolling of this down. I think it's stupid. So I just get rid of that. I go, instead of normal speed, I go to full speed. Because why? You know, so it knows the whole line, but just for anticipation, it slows it down as if the thing's actually running, which is the dumbest thing in the world. But so we just change it to full speed, and that way it plots it all the way. And notice by default, it plotted all 3 lines: the birth rate, the death rate, the constants. It actually plotted everything. I don't want it to plot everything, so I can create a new plot or configure this plot. I can say add display, and I want to say show me a time series, and I'll call this time series stocks and flows. And then under their data, I can say I want the bacteria stock, I want the population birth rate, and I want a population death rate, and that's all I want on there. And then I can go down through here and I can edit elements of the plot, like the labels I want on the plot, and so on and so forth. I can do all of that. I can even say whether I want a legend, and by default, it chooses the position. I can say I don't want any legend, I'm gonna leave it as automatic. If I do that, then now I see up top here, I had the default display, which plotted everything, but then I have my new stocks and flows display, which only plotted those 3, and it gives me the same output that I would have got before. And if I want to turn off these things, I can turn off pop birth rate, pop death rate, and there we go. Exactly the same as we got in Vensim, exactly the same as we got in Excel. So if I'm okay with this, this plot, I could take a screen capture of this. There's a way to export an SVG of this thing, but a lot of people don't like working with SVG files. So instead you can take a screen capture of this, or you can export your data in a tabular format to bring into Excel. How do we do that? We hit add display, then we choose table, and then I can call this like, you know, output table. And then I can choose what data do I want to put in it? Well, again, bacteria, birth rate, death rate. And then I can hit apply, and it shows me exactly the same thing we would get in the spreadsheet. And look down here, it says download CSV. If I click on that download CSV, it's outputting, it just brought in this output table, it put in my downloads folder. And that is a file that I can directly open in Excel. So if I just double click on it, it opens it. This isn't the one generated in Vensim, this is the one generated in Insight Maker. But if I highlight those first 2 columns, time and bacteria, and I go to insert, charts, scatter, again, gives me exactly the same result I've been getting. So we can do all the same things in Insight Maker and Vensim and Excel. Choose the tool, well, between Vensim and Insight Maker that you feel most comfortable with and that works the best for you. I don't care whether it's Vensim or Insight Maker. I will, whenever possible, try to do examples in both, because some people have better luck in Insight Maker and some people have better luck in Vensim. But I hope you see that lessons we learned in one transfer to the others. All right, so any questions about those 2 tools? Yeah. Changing the link. Okay, so it looks like you've created your handle, that little blue dot. Yeah. Just grab the blue dot and then drag it upwards. It looks like maybe, oh, you let go there. Okay, oh, I see. So it looks, so in your case there, I think you've created, actually created a handle for the flow. So hit your shift key and then click on the green line somewhere else here, like there, and try grabbing that blue line and dragging it up. Let go. Yeah, for some reason, what I would do is redraw, just go ahead and delete and you can just hit like backspace, I think.
Okay. Like that?
Yeah, and just redraw the flow and try redrawing that link. Yeah. You can use whichever one you want. Yeah, and then so examples I'll give in class after the midterm, I will try to, whenever possible, use both to show you how to do the same things. But I traditionally have always used both because Vensim, like we can see on some people's computers, it crashes all the time. And so this is a hedge against that. But now Vensim's getting a little more stable. I think Vensim, in some ways, is a little nicer because it's a desktop-based tool, but there's some aspects of Insight Maker I still like. So again, it's really up to you. All right, any other questions? Online, it looks like most people can still hear me. There's one person said the audio dropped out. Okay. All right, good. So that was our little Vensim Insight Maker tutorial. Now let's flip to the chapter. And we may not get through the whole chapter, but I think that's okay because the chapter is sort of rehashing a lot of the stuff that we've already been doing. So let's, it was more important for me to get you some exposure to Vensim and Insight Maker. So let's flip the sharing. Share screen.
And the term is next Thursday,
Right, and so, well, I'll go over this towards the end here, but we're gonna have a review session on Tuesday. Stage 1 of the midterm is on Thursday. So just give me a second here to. All right, there we go. Okay. All right, so, all right, I think we're back and sharing. All right, so let's, yeah, so like I said, hopefully a lot of this stuff from Morecroft looks familiar. It just kind of is using kind of different example systems, but hopefully you kind of see the same type of lingo. And so the focus of this chapter was, introducing us to these dynamical system models with stocks and flows, where our stocks kind of represent our the main kind of memory in a system, and the flows represent the processes that cause systems to change. So if you took a snapshot of a system and say, what's the temperature right now? What's the number of students in the class, et cetera? Those are stocks. But then if you want to say, well, how do we get from one state to another? Like what caused a student to leave the class or come into the class? Those are flows. And so that's kind of where we're going with this. And so flows make stocks change over time. They had this example where you're modeling the number of instructors at a university, and you'd say, well, at any instant of time, there are, 600 instructors at a university or 60 or whatever. What causes instructor count to go up? Those are recruitment. So we can model how much recruitment we have per month. What causes instructors to go down? That's turnover, them leaving the university. And we can model how many instructors leave the university. You put those two things together, and the net effect is what happens to instructors over time. And so we can model this mathematically by saying, how many instructors do we have initially? That's our initial condition that goes inside here. And this formula, which is Morecroft writes out explicitly, this is what we wrote out in our Excel spreadsheet that Vensim and Insight Maker are doing for us. And so this basically, this first part, instructors at time t is equal to the instructors at the previous time step, the dt before now, plus the net flow, recruitment minus turnover, times dt. So this is what's going on behind the scenes and all that I made you sort of force you to do manually in Excel, which now that we're in Vensim and Insight Maker, you're only ever going to have to write the inflow formula and the outflow formula. And if you tell Vensim for every stock, what the inflow is and what the outflow is, behind the scenes, it will write this formula for you and solve. So if we were to look at this formula to sort of see what are we really doing here, this formula down here, I can rearrange by moving instructors t minus dt to the other side of the equation. That's all I did here. And then I can look at this and divide the whole thing by dt. And this is an equivalent expression of what happens at every time step. Now, if you look at this, this should look kind of familiar from calculus class, because if you take that little dt and bring it all the way to 0 to make it super, super small, like I tried to do in Vensim when I made it like 0.001, then what we get is the relationship from one time step to another is an approximation of the relationship between a stock and its derivative. So the derivative of a stock is equal to its net flow. It's inflow minus its outflow. The rate of change over time of a stock is its net flow, the inflow minus the outflow. That's all we're doing when we're building these models, is building effectively these calculus expressions down here. Okay, so when we run the simulation, so this is kind of what we're writing when we draw the model. And then when we simulate and it shows us a behavior over time, this is what it's solving for down here. It takes your initial condition for whatever all the stocks are, and then it takes the integral from 0 to whatever time you set as your end time of all the net flows for all the stocks. And that generates stock trajectories over time. So they all start wherever you said them to start, and then they maybe rise or fall based on what happens to these flows. You're just taking the integral underneath the flow formulas that you put in. That's what's going on in each one of these things. So this is the way we draw it in Vensim or Insight Maker, and they're just equivalent to all of this stuff down here. That's all we're trying to say here. Okay. All right, so with that in mind, we can start reasoning using our old calculus-based insights about what we might expect when we simulate simple systems moving forward. So if the recruitment minus the turnover was constant over time, we might say, well, what shape would the instructors look like over time? Well, all we're really asking here is what happens when you take the integral of a constant. Now, I'm not going to ask you to take an integral of a constant, but I'm hoping that if you sort of reflect fondly on your first calculus course, then you'll remember that when you take an integral of a constant, you get a line. So with its slope being whatever that constant was. So if the recruitment minus turnover is a constant 5, then I would expect that when I plot the instructors over time, it would be a line with slope of 5, basically mean every time unit, every month, we gained 5 instructors. So that's kind of what we would expect. And so if we go ahead and do that, we simulate this in Insight Maker or Vensim, then I can plot. So remember how they do this. They've got the legend up here, 1, 2, and 3, and then the lines are labeled that way, 1, 2, and 3. And then on the left here, this is saying that this axis only has 2 numbers, 80 and 20. It's saying that 80, the top number, goes along with instructors, and the 20 goes with both recruitment and turnover. That's how we read this graph. And so this is saying that when line 2, which is recruitment, is stuck at a constant value of 5, and line 3 is a constant value of 0, then recruitment minus turnover is a constant value of 5. And so the instructors, as expected, is has a line of slope 5. So if I go over 1 unit, and in the instructor units, it will go over 5. If I go over 10 units in the instructor units, which is around here, it should go over around 50. So, and that's, if 80 is up here, then 50 is about down here, which is exactly what we see. So this is doing exactly what we would expect. It's a relatively simple thing. And so what they did is they said, and this was, I know this came up a lot in the perusal, what's causing this outflow to change? And in this case, the simulator is causing the outflow to change. So the person hitting run, they run this for 12 months, and then they manually went in and paused the simulation. And they said, for the next I forget, 12 months or something like that, then we're going to have the outflow rise linearly. And then once we hit that next, whatever, at month 28, it's going to level off again. And so they imagine a scenario when, for reasons that we have not modeled, so this is exogenous to the system, we are going to model the outflow as rising and then leveling off again. So there is no process that explains this. This was just a scenario that the person experimenting with the simulation decided to try. And so what we end up getting here with that scenario as they put in here is we see these different kind of regimes. And so we see regime A is when we've got a constant net inflow, and not surprisingly, the instructors is a line of constant positive slope. And then we go over to regime B, and at this point, the outflow is rising toward the inflow. And so in this case, the net inflow is positive, but it's decreasing over time until it hits 0 at this point here. So not surprisingly, you get this kind of parabola here where it keeps rising, but it rises less and less steep over time. And then when you hit this boundary where these two lines meet, then it's at its maximum. That's when the slope is equal to 0. It's exactly as we'd expect. Then we go into the next regime where we have an increasing net outflow because the turnover is now rising and it's always above the recruitment. And so at this place, we have the parabola turns over and we get this sort of acceleration in the loss of instructors from the university until somehow, like maybe right here, they raise everyone's salaries and they can manage to control the outflow so that it doesn't keep rising. And so then we're in section D where we have a constant net outflow. And then we get the mirror situation where we still get a decline in instructors, but it's not accelerating anymore. It's a line of slope equal to this difference. So that's how we interpret that. So the simulation results are exactly what we'd expect mathematically. So are there any questions on the interpretation of this graph? Or how to read this funny graph here. So it is important to know how to read these graphs. Just because the textbook we use, this is the graph they use all the time. So I might use these graphs on a midterm or whatever with a similar sort of lineup here with the axes and everything. Okay. Gesundheit, yeah. So, if I want to generalize this, we could say, what do these computers give us? Computers give us an alternative way to do calculus. Now, Newton, Isaac Newton or Leibniz, whoever you're sort of saying is like the founder of calculus, didn't have a computer. So they used analytical methods instead. But imagine if somehow you gave Newton a computer. It's my claim that I don't think calculus would have been invented because numerical methods would have been just as strong. The only reason he came up with a symbolic way to do it is because that's the only thing that was available. So let's think about it. So supposedly an apple falls and hits Newton on the head and he says, gravity. And he tries to come up with a mathematical model for explaining gravity. So imagine the apple here. He says, well, an apple can be described by its position, sure, but it also can be described by its velocity. And its velocity is being changed by the force of gravity. So we can say that it has some initial velocity and so we have the height of the apple and we have the initial velocity of the apple. So there's initial height and initial velocity. And we can describe the relationship, the rate of change of the velocity, the flow. So we can say there is a single outflow of velocity that's equal to gravity. Or you could say there's a negative inflow to velocity that's equal to gravity. So we can draw that here. So we can say that there is a stalk called upward velocity, and it has a flow, which is the change in velocity over time. And we'll just say it's a negative flow. I could have drawn this as an outflow and it'd be a positive, but because it's generally written like this, I just drew it as an inflow that's negative. So that's my stalk for how velocity is changing. But then I can say, but velocity is the rate of change of position. So I can create a new stalk called height. And what's causing it to change? Well, it's changing exactly the same as velocity. So whatever the velocity is will be exactly the rate of change of height. And so this here is identical to this model up here. This model up here, this is how Newton would have done it and would have solved it using fancy, analytical tricks. But if Newton had a computer, he could have drawn this and then just simulated it and got the same result, which we can see So this is the mathematical result up here. This is if you were to solve this using good old-fashioned calculus. If you were to plot these things, the position over time and the velocity over time, you would get the red line for the velocity, the blue line for the position. But I didn't plot these. I drew this in Vensim and hit simulate, and it gave me the exact same thing. So this is an alternative way to do that, but you get to skip the analytics. That's what stock and flow diagrams do. So any questions about that? So yeah.
Right. So you're saying that like calculus still existed, it's not analytically, like you created the whole version of it?
Yeah, right. So I'm saying that, so the calculus is a analytical method to deal with things that change over time. And so Newton said, how do I, so he came up with the idea of, well, we have state variables that are like these snapshots, and we know that there are rates of change of those state variables. And so I can come up with a model that says that, the velocity is changing due to acceleration, position's changing due to velocity. But then after that, he had no way to then say, given that I can understand how acceleration works and how velocity works, how do I predict where the apple is going to be? The only thing Newton or Leibniz could do is come up with the symbolic version, which we all learned in our first year of calculus or whatever. But if you had numerical methods, you could forget all that symbolic stuff, load it into Vensim, hit play, and you wouldn't get a formula out. And maybe there's value to that formula, but you'd still be able to predict the position of the apple through its whole arc, is all I'm saying here. Yeah.
So my question is, and I don't know if I remember this correctly, but like in calculus, when you take the derivative, it's like position, velocity, acceleration, keeps going down.
Jerk, et cetera, et cetera. Yep.
Right. Can you do that in Vensim?
Well, so yes, because you can, in Vensim, you know that, like, if I want to plot height, I can plot the flow, the net flow into height, and that's the height's derivative. So if you want to plot the derivative of height, you just plot height and its flow. Now, and likewise, if I know velocity, if I want to plot its derivative, I just plot its flow. It's just like in the toilet model, I said, you got this rising thing where it rose up to 15. And I said, if you wanted to, you could have plotted the flow. And that was something that started at 15 and it went down to 0. And I said that those two things are related. Whenever you go into Vensim or Insight Maker and I say, I want to plot that and that, what you're doing is plotting the variable and its derivative. Other questions? Okay, great. All right, so so in the chapter, so the challenge we have here is building these models. And so the very first thing we do is defining our state variables, defining our stocks, our asset stocks. And so I like a little bit this conversation that Morecroft has about tangible and intangible, although I saw it does cause a little bit of confusion as I saw in the perusal. And so tangible stocks, all Morecroft is saying here is the tangible stocks are the things that are easy to see with your eyes and hold with your hands. They're tangible. I can say that if I'm modeling a TV station, then these are the things that I actually can go up and kick with my foot or knock on with my hand. They're physical things that actually definitely exist in the TV station. That's what we're calling tangible stocks. They don't differ mathematically. Vensim doesn't care that they're tangible, but they're the ones that are going to be easiest for you to come up with. The ones that'll be harder for you to come up with when building modules are the intangible stocks, which are these like program quality and languages. You have to ask yourself, what are other sort of snapshots of the system that are somehow more abstract? At any instant of time, there's a certain number of languages represented at the TV station. At any instant of time, there's a certain program quality as you go from one network to another. And that program quality might change over time. Maybe Netflix's earlier productions versus Netflix's later productions might change in quality. And it really matters what era you're in to sort of say how that's going to affect Netflix's future growth. So that's why we might need program quality. It will change over time, but it's hard to see program quality. So these you have to come up with and then debate whether you've come up with all the right abstract ones. But once you've come up with the two of them together, then we have a full description of the system, the tangible and the intangible together. So that's the first challenge. So we need the intangible stocks because they matter, even though they're not physically there. Yeah.
So with the intangible stuff like program quality, that's more like a subjective thing.
Right. I mean, it's all subjective because it's which variables you're going to include. But the trouble with intangible stocks is they're harder to see that they exist. So I could actually argue that if I'm modeling the dynamics of a TV station, maybe it really doesn't matter how many transmitters the TV station owns. That's something I could model, but maybe it's not really driving much of the system. So I could choose not to include that, or I could choose to include it. That's a subjective decision, which goes along with my hypothesis for what matters. And that's what I'm effectively doing, is testing my hypothesis about what matters. But the intangible are just harder to come up with because we can't see them. We have to sort of say like, you know, and then we have to figure out how to measure them, how to model them, and that becomes difficult too. All right, so that's my why intangible. Other questions about this idea of how you pick your stocks or what stocks are?
So
Yeah.
I understand, you just explained it, but like, how would you add value to it, to like program quality? So that was
What do you mean by add value to program quality?
add a numerical value to it.
Okay, so the question is, how do we model this numerically, program quality? And that's a great question. So that is going to be somewhat arbitrary, and that's why these converters are going to be so important. So we can say we're going to model program quality using, I mean, program quality, you could say it has to do with a rating system, perhaps, like some Nielsen rating system or whatever. And we could imagine then that increasing in quality is increasing the Nielsen ratings or something like that. Or there might be some other metric. So you have to come up with something, and it might be an artificial metric, but then when you connect it to everything else with converters, then you're gonna have to say for every unit of whatever metric we chose for program quality, then we're saying that for every increase in that unit, no, it's gone away. For every increase in that unit, then for program quality, it's going to cause a certain increase in other things that are in the system. So that, so of course, the units you choose there, it'll all have to be calibrated. So in the end, you may just be predicting qualitative changes, and you may have to end up calibrating your converters, which convert from a unit of this to a unit of transmitter increase. Like as you increase your program quality more, that'll end up causing you to allow you to buy more transmitters. And that conversion from program quality to transmitters might require calibrating that conversion ratio by asking like, well, how would I model Fox's program quality versus NBC's program quality? And in my model, I see as Fox's program quality went up, they bought this many more transmitters. Well, now I can use real data to try to do that calibration. Any other questions about this? Okay. So once we have all our stocks, then we need this coordinating network, which is kind of the answer I was looking for on that reading exercise. But if you said in causal links or information flows, that's fine too. And this is just the thing that formally establishes the relationship. Like I was just saying, there may be a relationship between program quality and how many transmitters you can buy in the next year. Because as you increase program quality, it might increase your revenue. Maybe revenue is another stock that I needed there, and program quality will affect revenue, and revenue will affect the number of transmitters I buy. So, but as we saw in Vensim and Insight Maker, I can't write formulas unless I've given myself access to that information. And that's what goes on with these links. And that's what's kind of shown here. So if I've got A has two incoming links coming into it, and that means that inside A, there's a formula which can make use of B and C. I can't make use of anything else, but I can make use of B and C because they've been drawn connecting to A. So any questions about what we mean by giving access to that? So we now seen in Vensim and Insight Maker, you can drill down into A, and then you can get these connections here to B and C. Okay. No questions there. All right, so the other thing that he talks about in here are sector maps. And so that's kind of another term here. This is not a term of art necessarily. This is something that Morecroft uses as a construct to simplify model building. So we'll talk about sectors here. And so the idea here is if you have a very large model, it's going to be a real pain to build it all at once. Simple models, not so much. You can just sort of start with that, but large ones, we might want to break them up into components and then connect the components together. So like in a causal loop diagram, I have a relatively simple system, but this might not be enough detail to actually get the dynamics of this thing going. So once I start adding in dynamics of how you get from drug-related crime to drug seizures, then I get this ugly system. And so I break that thing up and I say, I'm going to simulate all the variables I need for community, simulate all the variables for police department, et cetera, et cetera. There will be common variables that will mark connections between them, but I kind of build them in isolation just to simplify the modeling process. And so this is the way each one of those would look. So the community is just this simple thing up here. It doesn't even have any stocks in it. Drug users has got street price as a stock, and then it's got some coordinating networks, and so on and so forth. And I've colored in like things that show up in multiple communities. So drug seizures shows up down here in street market. It also shows up here in police department. So on paper, I could imagine drawing these things out, but then when I actually need to implement it in Vensim or Insight Maker, then this drug seizures would be the same as that drug seizures. And so these incoming links would actually end up being anchored here, the drug seizures, and vice versa. So that's how we connect these sectors together. Vensim and Insight Maker don't know that these sectors exist. These are just there to make it easier for you to break the modeling process up. Question.
That's what my question was going to be. Can you make like the sectors in Vensim and then break them out like this?
Well, so there, and so I actually put, I say videos down here. I've got some tutorials online for how you can organize your stocks and flows in Vensim and Insight Maker to create these sectors just to make the model building process a little cleaner looking. But that's purely for organizational. So you can create like pages in Vensim where this is my drug users page, this is my street market page, and you can connect variables from pages to pages together, like vias in an electronics piece of diagram or something like that. So you can do that, but Vensim doesn't care. That's just purely for your convenience. Okay. All right, so how do you then set up the formulas for these things? So I just want to at least get through a couple of these examples because this is like really the meat of these system dynamics models. So we can focus on one of these sectors, the police department sector. And I can then look at one of the stocks in the police department sector, number of police allocated to drug busting. So this is number of police allocated to drug busting here. And it's got this flow, change in allocation of police. That's the derivative of number of police allocated to drug busting. And I want to say, what do I write for that derivative? And so one of the things that's really helpful to figure out these formulas is to think about the units. I know that number of police is in units of police officers. So I know the change in allocation police is going to be whatever the stock units are per unit time. I've said for this model, my unit time is month. So I'm going to look for a formula which gives me police officers per month. Now I might have figured out that there are two things which affect the rate of change of police officers. How long it takes to move staff, how long it takes to get a police officer from the police academy into the force, and how many police officers I think I need on the streets. Those two things probably are going to drive the rate of change of these police officers. So now I just have to figure out how to put these two things together to get a formula that makes sense and, as a sanity check, has the right units. So what I might do then is I think about it, I say, well, this is what's going on behind the scenes as I'm simulating here, where this is the reason why flows or rates, they have to be stocks per unit time. That's all I was saying before. So then I have to say, well, then how do I get this stocks per unit time? This is me just stepping through everything I just said. Now, when I look at what's available to this rate of change here, the current number of police is available, and how many police I want on the streets is available. So it kind of makes sense that probably the difference between those two is driving the rate of change. So this is how many I want on the street minus how many I actually have here. This is like the tank gap in the toilet tank model. This is where I want things to be after things settle out. This is where things are now. So that's probably important, and it gives me the right units for the numerator, the stock units. So then I've got this other thing I haven't used, time to move staff. And so this is all I'm saying, it's just the tank gap. So then I can say, well, time to move staff, that is, it's already got the units months. that would go in the denominator of this flow. So maybe I'm gonna wanna just divide by that. So I've got the number that I need divided by how long it takes to get them into the force. And that actually makes sense from a bacteria perspective. You can kind of think of like the empty number of cops who aren't on the force are kind of like bacteria that are dying every time a cop joins the force, a new bacteria dies. And this is like the lifetime they take until they die off and finally reduce that number. So then I put that together, and there's, I got my flow equation. And it's, again, exactly the equation we had for our toilet tank model. So that's kind of an example of how we build these things. So the rest of the examples here, again, I'm just going through the chapter stuff. I'm going to skip over, and we might revisit them, but they're just kind of an example of how we can use these stocks and flows. So looking forward, the announcements here is that, so after the midterm, that's our next chapter to worry about. We're skipping chapters 4 and 5, although they might be useful when you're thinking about, when looking ahead, it might be worthwhile to skim, but the next chapter you're absolutely required to eventually get is chapter 6, but not until after the midterm. Start forming your final project teams. We'll need actually you to sort of formulate your team basically the Saturday after the midterm, effectively. That's what this is saying here. And then your project proposal we do basically a week after that. And it's a really short document just saying this is the system that I want to study. So assignments, there's that assignment D3, which is our Vensim toilet model, just redoing your toilet model in Vensim and the muddiest point. Otherwise, midterm coming up. So Tuesday, we're gonna have a review session. I'll bring slides. We don't have to use them. It can be driven entirely by you. Thursday, stage 1, you can come to class and take it here. It'll be on Respondus, or you don't have to come to class. Thursday, Friday, and Saturday is the availability window. You can start anytime during that time, and then you got 90 minutes from after you start. Then the next week, you don't get your scores, you don't get the solutions. Then Monday, Tuesday, and Wednesday, the availability window opens, and that whole entire time, you've got open book, open notes, and collaborate. So you can come to class on that Tuesday and collaborate in class, and I'll be here, but you don't have to. Study resources are available, but let me just end here so you guys can get out of here, and then I'm happy to take questions for those who want to stick around. Otherwise, we will just pick up with the review session. So the question I have here is, what is the initial condition for the bacteria stock in the bacteria model? So what number did we use for the initial condition in the bacteria stock for the bacteria model? And that's all I've got for you for today. So again, happy to take questions after class. Otherwise, have a good weekend, and we'll see you Tuesday for the midterm review session.
What number of bacteria That's great. Well, rated.
Is it gonna be mostly just like concept-based questions with like the diagrams that you want us to do, or like you're gonna put diagrams there and then ask us questions about those? Have you started on that?
Well, there'll be kind of a mixture of both. I definitely will show you some diagrams and ask you questions about them. I might show you incomplete diagrams and ask you how to complete them. Yeah, right. I have sample midterms from previous semesters.
I haven't started.
Yeah, if you-
like practicing yet. I feel like probably tomorrow.
Okay,
So,
well, they'll be
I'll
very
do
similar
that.
to that, especially the more recent ones.
Really?
But yeah, so just like, and we'll talk about the format on Tuesday as well. But if you take a look at the sample ones, especially the one from like last semester, I would say calibrate to that.
Okay, thank you so much.
Yep. Hi, sure. Hold on, let me just make sure so we don't have to record everything. So it looks like, no, okay, so I'm gonna go ahead and end the meeting. So we'll see everybody next week.